Introduce you to James Harrison is a data engineer at Flowminder, and he's going to discuss today privacy by design for the next 50 to 60 minutes. So over to you, James.
Thanks, Sophie. Yeah, hi everybody. So I'm going to be talking about the privacy by design approach in this session and covering how to build data governance into data processing pipelines. I'm going to cover the 7 principles of privacy by design, the journey of data governance from the first stage of identifying requirements in the pipeline right through to when the pipeline is fully operational, and cover what happens if something goes wrong, if there's a data leak, a data breach, something like that, what happens then. I'll also cover the stages of privacy preservation during the data lifecycle from first data collection to eventual erasure of data at the end. And I'll also talk a bit about some anonymization techniques for protecting privacy in data sets, and I'll briefly touch on some emerging technologies in this area as well. The learning objectives of the session are, by the end, you should be able to describe why location data, including MPD data, is difficult to anonymize. You should be able to explain the concept of privacy by design, to describe the common stages of privacy preservation in an MPD pipeline, excuse me, to identify best practices for individual privacy preservation and for data security, and to identify data governance processes that should be built into an MPD data processing pipeline. I'll start this session by having a recap of the pre-reading material that I hope you've all been able to have a look at. I will then talk about how to build data governance into MPD for policy pipelines. I'll then talk about the stages of privacy preservation throughout the data lifecycle within these pipelines. And I'll finish off with a quick summary of what we've covered. So firstly, a recap of pre-reading material. So we're talking about location data here. So coming from MPD sources, this is going to look something like this example here. A subscriber ID, which here is pseudonymized. So this is just a randomized ID that corresponds to a specific individual, but doesn't give us any way to link to other data. So there's no names, phone numbers, or anything involved here. Just a unique identifier. Timestamp of location points, and then the location of the subscriber at that time, and that's typically going to be coming from a cell ID. So maybe it's a point location or a polygon area or probability of being in a particular location. That could take various forms. So our first question for you here, I think we should have a poll. Is this data set anonymous? I'll give you a moment to answer that. I'm not able to see responses and so on, but yeah, give you a moment to select an answer. Okay, so what did you think? Is this an anonymous data set or not? Interesting. So 64% of you have said yes, 36% no. The correct answer was no. This is not an anonymous data set. Although there are no direct identifiers, location data is still personal data. And this is because individual location trajectories are very unique. Even without the direct identifiers, phone numbers, and so on. Um, each person's individual trajectory over time is very unique. So even in very large data sets at coarse spatial resolution, that remains the case. And in the pre-reading material, I linked to a 2013 study which looked at MPD data from 1.5 million individuals, um, and found that just 4 randomly chosen location points were sufficient to uniquely identify the vast majority of individuals in that data set. So even without any direct identifiers, this is still personal data. So under the GDPR framework, for example, in Europe, individual location data is certainly classified as personal data. Um, and usually this would be classed as special category data, because, for example, if it reveals visits to hospitals or to places of worship, this can reveal other sensitive information such as health, disability, religious beliefs. So this is very sensitive data that we're dealing with here. As such, it is vital that we properly anonymize any MPD-derived indicators before they are released from our pipeline. And this can be achieved through techniques such as aggregation and various privacy-enhancing technologies that I'll touch on later. But also important to note, anonymization is a moving target. Over time, new methods can be developed to re-identify data sets that were previously thought to be anonymous. So just because a data set is deemed to be anonymous today, that might not remain so forever. So we need to keep this in review at all times. And then what is data governance? This is another thing I'm going to be talking about a lot today. Data governance, it refers to the policies, processes, and standards that are used to manage data assets effectively and responsibility. So this is balancing data protection of the privacy of individuals represented within the data with the usability. How effective can the data set be to serve the use case in question? And this covers aspects such as ownership of data and accountability for handling that data, quality standards, so how much can we rely on the quality of the data, access and security, who is able to access the data and how to ensure that those who are not supposed to access the data cannot do so. Compliance with whatever various regulations might be applicable in each situation. Data lifecycle management. So this is how do we handle the data from the point where we collect it throughout all processing stages up to retention or deletion of the data at the end. And also documentation of all of these processes. And privacy by design, what is this? Privacy by design is a framework for embedding privacy considerations into the design of systems and processes right from the start. And there are 7 principles for this. First one, proactive, not reactive, preventive, not remedial. So this is, we should be taking action ahead of time, anticipating privacy issues, not reacting after the fact to things that have gone wrong. Privacy should be the default setting, shouldn't require any action on the part of the user to choose privacy. That should be the default. Privacy embedded into design, it shouldn't be an add-on on top of the main product. It should be embedded right into the system. Full functionality, positive sum, not zero sum. It doesn't have to be an either or situation. We can have both privacy and functionality. It's perfectly possible to do both at the same time, and we should do so. End-to-end security, full lifecycle protection. So throughout the entire process of handling any sensitive data, that data should be securely protected throughout. Visibility and transparency. Keep things open. It should be important that anybody involved, especially the data subjects in any data set of personal data, should know what is happening with their data and should be able to see and verify that. Don't hide things away. And respect for user privacy, keeping things user-centric. It should be easy for users to make the privacy choices that they want and to understand what choices they're making. So I'll now move on to covering building data governance into MPD for policy pipelines. And I'll talk through the data governance journey, starting from identifying the requirements of the pipeline with regard to data governance, planning how to build those into the pipeline, data governance during the stage where the pipeline is in operation, and then finishing off talking about what happens if something goes wrong. So firstly, identifying requirements. We start off by specifying the use case. What outputs will be produced by this data pipeline, and who will be using those outputs, and for what purpose? That's going to determine all of the other aspects, like what data we need, how it will be processed, and so on. Identify the inputs. So what data do we need to create these outputs for this use case? And how sensitive is it? So some data sets, like the location trajectories from MPD data, as I've covered already, these are sensitive personal data. Other data sets, for example, auxiliary data sets such as calendar data, other population reference data may not be as sensitive. There will be different levels of sensitivity that we need to assess. And then what compliance requirements are applicable in this case? So this can be a range of things. So legal requirements, for example, the African Union Malabo Convention, or in Europe, the GDPR regulation. And then often there will be, well, in most cases, there will be national data protection regulations within different countries. As well as legal requirements, there will be industry regulations. So particularly when we're dealing with MNO data, the GSMA guidelines are going to be important to keep in mind here. And probably there will be some company policies, for example, MNO data handling policies, that also need to be taken into account with regard to compliance requirements on the data handling. And these requirements can constitute things like consent requirements. So what level of informed consent is required to be gathered from data subjects before the data is processed. Retention and deletion durations. How long do we need to keep hold of personal data after we've finished using it? And at what stage does that need to be securely erased? And data transfer restrictions. For example, does the personal data need to stay within the country of the origin of the data subjects? Does it need to remain within the premises of the data owner, in this case, the MNO? There are considerations such as these, which will depend on the exact case. They'll vary from case to case as to exactly what requirements are necessary. The next stage I want to talk about is the planning stage. So first thing is to do a risk assessment. Evaluate the risks before you start to build. So firstly, is the processing that's going to be carried out necessary and proportional? Is all of the data that we're collecting strictly necessary for the specified use case? And if not, it shouldn't be collected. Are we doing any more than we need to be and putting any additional risks on? Because we need to make sure we're not doing that. What are the privacy risks? There can be various privacy risks, and again, these will vary depending on the use case, but these will include, for example, the risk of re-identification of individuals in supposedly anonymized outputs from the pipeline. Also, a data breach is a potential risk if somebody manages to gain unauthorized access to the data pipeline and to the sensitive data within that pipeline. Also, potentially there's a risk of outputs being used for unintended purposes. Maybe we're producing statistics on vulnerable populations. If those fall into the wrong hands, potentially they could be used for purposes other than the ones that were intended. So once we've identified the privacy risks, how do we mitigate those risks? I'd like to give you a moment to have a think about that. Put some answers in the chat if you'd like to say, how do you think we could mitigate these kind of risks? Don't worry, I'm not going to be reading out any of your names, but I'll have a look through answers you give. Feel free to just send a private message to me or put it into the chat for everyone if you like. I'll just pause here for a moment to give you a chance to do that. What steps could we take to mitigate these sorts of privacy risks in our data pipelines? Anybody got any thoughts? I'll just hang on a couple of minutes more to give you a chance to put some answers in the chat here if you've got any ideas. Okay, so how do we mitigate risks? There are a variety of approaches we can take, and I'll touch on some of these again later, but these are things like encryption, making sure that the data are encrypted at rest on the server, wherever they're being processed, so that if anyone does manage to gain unauthorized access to that server, they still can't use the data because it's encrypted, so they can't read it. Access control, so ensuring that there are clear levels of control, clear levels of access enforced, so that only the people who are meant to have access to a particular data set do. Policies, so making sure that there are clear policies for how data steps are handled and um, how issues are dealt with in case there is a data breach, for example, and training of anybody using using the data pipeline. So that could be users of the outputs or anybody operating any stage of the data pipeline with access to the sensitive data, making sure that they are trained, they understand the risks, they understand the data that they're working with, so that we can minimize the chance of anything going wrong there. And sorry about the issue with the chat being blocked there. Just have a look at some of the answers that have come in. Thank you for this. Yes, very good. Security policies, security tools, checking for data breaches. access control. Very good answers. Thank you, everyone. And finally noting here that regulations such as in Europe, the GDPR regulation is an example of this, may mandate a specific and thorough data protection impact assessment process that goes potentially beyond this sort of rough risk assessment process I've spelled out here, that might require more formal and more in-depth risk assessment to be carried out at this stage. Another stage of planning is data classification. So important to know what data you have. So of the data sets that are being collected, and also intermediate data sets being produced within the pipeline, and the output data sets disseminated at the end. How sensitive is each data set? Does it contain personal data? What are the risks in terms of what could go wrong if that data got into the wrong hands? And then for each level of sensitivity identified, what restrictions are required in terms of who should or shouldn't have access to those data sets. How long does the data need to be retained? At what stage does it need to be deleted? What are the restrictions on the location where the data can be stored and processed? So a possible example of this, as I've said already, the exact details will vary from case to case, but it could well be the case that MPD location traces must be processed in country, can't be taken out of the country. Personal data can be accessed only by MNO staff, not by anybody external to the MNO. And any anonymized outputs from the pipeline still need to be encrypted and should be accessible only to approved third parties to make sure that these outputs don't fall into the wrong hands. The next aspect of planning here is the basis of processing. So what is the basis on which we are processing data? This forms the legal foundation for the use of that data. What's the purpose for which we're processing the data? What are the consent requirements from data subjects for us to be allowed to process the data? And what are the requirements on data retention? So a possible example here could be that there's no explicit consent required from data subjects because the use case is covered by public interest, but it's still necessary to give data subjects the opportunity to object to the data processing, in which case their data would need to be removed from the processing pipeline. It may well be the case that collected data must only be used for the specified purpose, and if any additional use cases are added, that would then require new legal agreements and consultation with the data subjects to get approval for this new purpose. And personal data perhaps should be, it may well be the case that it must be retained for 5 years after processing has been completed, and then after that to be erased. Another aspect of planning is roles, policies, and procedures. So we need to put in rules and processes in place for how the pipeline will be operated. So this includes roles such as data owners, people responsible for pipeline maintenance, people who are responsible for reviewing any kind of incident that occurs, a data breach or similar. And for each of these roles, we need to have clearly defined responsibilities for what those roles encompass. And we need to clearly record what those roles are and which individuals fall into each role, so that we have a record of that, and that needs to be regularly reviewed over time. Policies include things like policies for access permissions. So for each of the roles that we've defined, what level of access do people in that role have? What level of access is necessary to the various data sets in order for them to be able to perform their role? Data labeling policies. So as I said earlier, in the risk assessment phase and earlier, we need to assess how sensitive each data set is and what are the risks. From that, we can then label each data set with a different classification level, which determines how that should be handled, and we need a policy to describe that process. And procedures for things like data backup and recovery in case of data loss, incident response, handling things if something goes wrong, data retention and erasure periods and processes, and procedures for deploying and updating the pipeline. Important to clearly spell out and document these procedures ahead of time so that everybody knows what to do once we get into the operation stage. So now moving into that operation stage, what happens while data is flowing through the pipeline? So we want to have, to the largest extent possible, automated compliance. So things like data labeling and classification, this should be happening automatically as data flows through the pipeline, so we can easily identify what data we have and what the sensitivity levels are there. Retention and erasure should be automated as much as possible as well, so ensuring that a data set is securely erased after the retention period ends, so that it's not reliant on somebody remembering to manually go in and erase that data. Security is a key thing to take into account throughout the whole pipeline. So as I've already said, role-based access control, making sure there are clear roles and clear access control policies for who can access what. Server hardening processes to ensure that individuals who don't have access to a data set cannot gain access to that. And encryption of data so that even if somebody does gain access to a server when they're not supposed to have it, and they manage to extract data, they can't use that data. Data quality checks and metrics should be integrated throughout the pipeline. So I covered this in the session last week on data pipeline design, but it's also key for data governance, keeping clear quality checks and recording quality of data so that we know what's there and any issues with it. And also throughout the pipeline, audit logging. We need to keep a paper trail of who is doing what in the system and when, so that if anything does happen, if there are any incidents, we can go back, look at the audit logs and identify what went wrong so that we know how to prevent that from happening next time. So in the final stage of the data governance journey I want to talk about here, what happens if things go wrong? Because things can go wrong. Data breaches, and inadvertent use of output data that causes problems. We can't assume that these things aren't going to happen because they might happen. How do we protect against these things happening? And again, I'll pause for a moment, give you a chance to put some answers in the chat as to what do we do when things go wrong and how do we protect against this? Anybody got any thoughts here? Let's say we discover there's been a data breach. Some of our sensitive personal data has leaked out when it wasn't supposed to. What do we do? Okay, good. Yes, getting some good answers coming in here. Report to regulator. Yeah, inform people impacted. Have a data backup. Crisis communication and management plan in place. Disaster risk plan. Yes, yes, good. Definitely a recurring theme here of having a plan and following it. That's good. Yeah, thank you. So, some things to do here. Firstly, breach detection. So, in advance of an incident happening, we want to have processes in place that will function as early warning systems so that if there is a data breach, we can detect that as soon as possible and address it appropriately. And this will benefit greatly from having the compliance and quality checks automated throughout the pipeline and those audit logs recorded to support that. Then, if there is an incident, the response for that should be following the plan that we made earlier on. We should have clear policies, clear processes to follow, with roles and procedures clearly documented and that everybody understands. We follow the process. Now, this exactly what that process is will likely depend on the exact case. I've seen some good answers in the chat regarding reporting the incident to regulators, informing people impacted, things like that. Yes, the exact details will have been defined in that planning stage. So the important thing is we should have a plan, we follow it here. And then yeah, get down to the cause of what's gone wrong, identify it, and keep that in review. So we learn from the mistakes, we adapt to that, we put processes in place to stop that happening next time. We keep this in continuous review so that each time anything does go wrong, we learn from that, we adapt so that the same thing doesn't happen again in future. So now moving on to the stages of privacy preservation throughout the data lifecycle. So this is from data collection, so getting the data in the first place, pseudonymization as a first stage in the processing of MPD data, secure storage and access control throughout the processing of the data within the pipeline, anonymization of outputs from the pipeline, and then finally retention and disposal of the data. So starting with data collection. Again, I've touched on this stuff already, but purpose limitation. So we should already have defined clearly what are the purposes for which we're processing data, and we need to make sure we're collecting and processing only the data that's necessary for that and processing it only for that purpose. Ensure that we follow any consent requirements that are applicable, whether that's needing to get informed consent from data subjects ahead of time, or whether that's giving them an opportunity to opt out. We need to make sure that we comply with all the necessary regulations here. And data minimization is a key principle here. Throughout all of this, it's a simple and effective process to keep in mind. Don't collect any more data than necessary. Don't process anything that you don't need to process. Next stage, pseudonymization. So what do I mean by pseudonymization? This is replacing any direct identifiers in the data, such as names, phone numbers, email addresses, perhaps, with artificial identifiers, for example, by hashing those. The intention here being that we still have unique identifiers for each individual in the data set, but we can't link that to any external data just using those identifiers. Important to note, this is not the same as anonymization, as I covered at the beginning. The location data is still personal data, even without direct identifiers, because the location trajectories themselves are uniquely identifying. So a pseudonymized data set is still individual personal data, but it adds that extra layer of protection. It makes it harder to link to other data sets, harder to re-identify individuals in the data. This falls under the data minimization principle that I've just talked about. So if we're producing outputs at population level, we're not interested in specific individuals. So those individual identifiers are not required. In some cases, maybe we want to link to other data sets. For example, if we've carried out a survey and we want to link individual trajectories to survey data, maybe there does need to be some linkage there. And in that case, the individual identifiers in the other data set, for example, the survey data set, would need to be pseudonymized correspondingly so that the same identifiers are present in both data sets. And the data should be pseudonymized by the data controller, which in the purposes we're talking about here will be the MNO, before any other party can access the data. So if a technical service provider is carrying out the processing of individual level data, it would be important that before they can ever see that data, the MNO has already pseudonymized the data so that nobody else is seeing these individual identifiers, such as phone numbers. And to give an example here of what pseudonymization looks like, so in this left-hand table, we've got sort of data set you might see in like a CDR data set, for example, where we have the MSISDN, so the phone number, timestamp of CDR events, and then the cell ID that handle those events. And the pseudonymization step just converts those phone numbers into identifiers that can't be directly interpreted and linked to anything else. So we can see here, we still have a unique identifier for each individual. So the first two rows here both have the same MSISDN. So after pseudonymization, they both still have the same identifier, but that's no longer a phone number that we could call, that we could look up to find out who this person is. Next stage of privacy preservation is secure storage and access control. There are several aspects to this. So encryption of data at rest is a key one. And I should note there is a trade-off here between security and processing speed. So when we're dealing with large MPD data sets, storing those encrypted might add quite a lot of overhead through the need to decrypt them when we're loading into memory to do some processing on them. And if those are stored on a very secure server with very limited access, maybe the encryption is a step too far that's not really necessary, not really justified at this stage. But then with later data sets, smaller data sets later on in the pipeline that may be processed on less secure servers, in that case, we might want to be making sure those are encrypted when they're sitting on disk at rest. Access control should follow the principle of least privilege. So nobody should have any more access to personal data than they absolutely need to carry out their role. And this should be linked to the predefined roles that were set out at the planning stage. And access control should be clearly documented so that at any time we can easily look up, see who has access to what. Server hardening, this is a very big topic. I could do a whole session on server hardening, but just to cover the sort of thing I'm referring to here, this is things like making sure that software is kept up to date um, within the data pipeline so that security updates are included. Password policies in place, for example, password rotation, um, ensuring that passwords must be sufficiently strong. Firewalls to control access to the servers, make sure that we limit as much as possible the access routes into and out of the servers handling personal data. Secrets rotation, so for example, encryption keys, database passwords, make sure those are rotated over time so that if there is a leak, that that's only a vulnerability for a limited period of time. And penetration testing, so testing these various defenses, making sure that there are no holes, and if there are any holes, catching those. Data classification. So again, I've already touched on this really, but clearly defining the various sensitivity levels of the different data sets and the corresponding policies for how the data sets of different sensitivity levels must be handled. Encryption in transit as opposed to encryption at rest that I've already covered. So when we're communicating data between different systems within the pipeline or disseminating data at the end of the pipeline, make sure we're using secure transfer protocols. So if this is over the internet, for example, using SSL to make sure that data are encrypted while they're traveling over the network. And as much as possible, using private networks rather than the public internet to communicate data between systems. And audit logging, again, I've said this several times, so I'll keep reiterating it. Make sure that everything that happens in the system is logged and make sure that those logs are monitored so that if there is anything suspicious going on, that will get caught. Next stage of privacy preservation I want to talk about is anonymization. So as we've already covered, it's very important that individuals should not be identifiable in output data. There are various methods we can use to achieve this. These include aggregation, so summarizing data per group. So this could be it rather than reporting a home location per individual, we report the number of residents per location. Redaction, so hiding or excluding sensitive subsets of the data. So if there are particularly distinctive individuals or small groups that really stand out from the rest, maybe we exclude those, don't report those in the final output data sets. And then statistical disclosure control techniques. So techniques for preventing disclosure of personal data from output data sets. And this includes things like suppression, so hiding data fields that might reveal identities, such as, for example, age of individuals. Generalization, so broadening categories. So rather than just hiding a field entirely, grouping that into categories. So rather than reporting exact ages of individuals, but age bands 20 to 30, 30 to 40, things like that. And an extension of that idea, top and bottom coding. So particularly at the extreme ends of a category. So using this age example again, the oldest individuals are likely to be more distinct. So we could group extreme values. So maybe we can still report exact ages for the more common ages, but then we'd group anyone over 85 into a single category. And then the final point here, perturbation. So adding some noise to the data. So with the age example, maybe we randomly add a year or two to people's ages in a way that is a small enough amount of noise that it doesn't significantly affect the statistical summaries at the end of the process, but it means that there's less risk of revealing specific data about individuals. And one principle of anonymization, one method would be k-anonymity. So this is not the only anonymization metric, but it's a simple one to explain here, and it's broadly effective. So ensuring that every individual represented in a data set is indistinguishable from at least k minus one other individuals for some number k. So to give you an example, and this is not an example of an MPD data set, but this might be something you'd see maybe if you're linking with survey data. We have a data set here where we have pseudonymized names of individuals along with age and gender. And if we want to achieve k-anonymity with k equals 2, that means we need that every individual in this data set to be indistinguishable from one other, at least one other. So in this left-hand table, that's not the case. There is, for example, only one person here who is age 30 and female. If we suppress the age entirely, then we achieve k-anonymity because there are now 2 individuals that are female and 2 that are male, and those are not distinguishable from one another. Alternatively, using generalization, with the same example, we maybe don't need to lose the age information entirely. We can group that into bands. So rather than reporting exact ages, we can say age 20 to 30 and age 40 to 50. And now, again, we achieve k-anonymity with k equals 2 in this example. And we can apply a similar process to aggregated data. In this example, it's in this case, it's not technically k-anonymity, but it's essentially the same principle, ensuring that all groups represented in the aggregated data represent at least k individuals. So this is something we might see as an output aggregate from MPD data, where we've got locations at the level of towns and a resident count for each location. And if we want to anonymize this with k equals 20, you can see this bottom row here, the resident count in District 3, Town E is less than 20. There are only 12 individuals there. So one way we could anonymize this would be using redaction. So we just exclude that row entirely. And maybe, depending on the use case, we might need to keep a total of summed over all of the redacted categories at the end so that we know the overall total. Or alternatively, generalization. So here, rather than reporting counts at the town level, we can go to the district level. So summing up the counts per district, we then find that each district has more than 20 individuals. So now we've achieved this k equals 20 requirement here. And there are various more advanced privacy enhancing technologies, a lot of which are still very much in development. I'm not going to go into much detail on those here, but just to give you a flavor of some of the technologies that are out there. Differential privacy is one. So this is a process of adding random noise to mask individual contributions to an anonymized data set in such a way that we have a mathematical guarantee of the risk of disclosure balanced against the size of the effect on the output statistics. Federated learning, where rather than bringing all of the data to train a machine learning model, for example, into a central location, we take the model onto decentralized devices so that the individual level data stays with the individual, and only the model trained on that data is then taken back to a central place. Homomorphic encryption, this is an advanced encryption technique where computations can be performed on encrypted data in such a way that if you then decrypt the output of the computation, you get the same answer as if you'd performed the original computation on the decrypted data. Secure multi-party computation is, again, a cryptographic approach where multiple parties can jointly process all of their private data together without the inputs from each individual party being revealed to any of the other parties. And a similar thing can be achieved with using, for example, cloud-based secure enclaves or trusted execution environments where data can be processed in an environment where no individual actually has access, but there's verification of what's happened there within that system. And finally, synthetic data. So rather than developing models, producing visualizations and so on from real data, we can produce a fake data set that reproduces patterns from the real data, and then use that instead. And I'll link here to the UN Privacy Enhancing Technologies Guide, which gives much more detail on these. So I'd encourage you to have a look at that if you're interested. The link to the UN PET guide should be in the OLC for you to access. So then the final stage of privacy preservation, retention and disposal. So we need to ensure that we keep secure backups of the data, so that if the primary copy of the data is lost, we have a backup that we can restore from. And that backup, because it contains the same data as the main copy, needs to be secured in the same way with the same access control and so on. And yeah, that's important not just for being able to recover if there's a data loss incident, but also for compliance purposes. If we have retention requirements, we need to make sure to comply with those regulations that we don't lose any of the data that needs to be kept. Automated retention policies, as I already said earlier, automating the process of erasing data when it's no longer needed and making sure that up until that point, the data that needs to be retained is securely stored. Deletion requests, we need to make sure that if a data subject withdraws their consent or objects to data processing, we can efficiently enact that. We know what data sets have been produced with their data, how do we go in and remove that data from the processing. And to achieve all of these things, it's key to have documentation of what data we have and how it's being processed, data classification to know the sensitivity of each data set, and data lineage. So for each data set, what other data sets have fed into that, so we have a clear view of how the data is flowing through the system. And I'll just wrap up with a summary. So started off by pointing out that location trajectory data is sensitive personal data, which is very hard to anonymize. I covered privacy by design, which is an approach to embed privacy considerations throughout processes and systems. Data governance needs to be taken into account throughout the implementation of pipeline, from the initial planning stage to deployment, and then through ongoing maintenance of the pipeline, and also throughout the whole data lifecycle, from collection of data through all the processing stages up to final erasure. Outputs from the data pipeline should be anonymized, for example, using aggregation, k-anonymization, and/or more advanced privacy-enhancing technologies. And it's important to have well-defined policies and roles for maintaining the pipeline, along with comprehensive logging and monitoring in order to protect the sensitive data that is being processed. Thank you. So I'll just finish off by pointing you to some further reading. These links are available in the OLC, so don't worry about trying to copy them down now. But the handbook on MPD for official statistics from the UN Big Data Working Group is a very useful additional resource for this kind of material. I'll also point you to this paper from 2021, Guiding Principles to Maintain Public Trust in the Use of Mobile Operator Data for Policy Purposes. And then finally, as I said just a moment ago, the UN Guide on Privacy Enhancing Technologies for Official Statistics is an excellent resource for finding out more about these privacy enhancing technologies. Thank you.
Great, James. Thank you so much. Great. Thank you so much, everyone. I wish you a great rest of your day and hopefully see you all next week. And thank you, James, again so much for your training.